Okay, so today's lesson is going to be on test of convergence. And before we begin, I just want to do a general definition of convergence for review. So suppose we have this function f of x, which is positive for x greater than or equal to a. Now, if the limit as b goes to c of the integral of a to b of f of x is a finite number, then we say that the integral from a to infinity of f of x converges, and otherwise the integral diverges. So the first test we're going to cover today is the comparison test. So just for an example, say we have the series from n equals 0 to infinity of 1 over 3 to the n plus n. Okay, so first it's important to note that all the terms in this series are going to be positive. And let's just call this series a sub n. Now, you may realize, for the sake of the comparison test, that the series 1 over 3 to the n plus n is less than 1 over 3 to the n. This is because the plus n at the bottom is going to have the numerator always larger, therefore making the entire fraction smaller. Therefore 1 over 3 to the n plus n is less than 1 over 3 to the n. So remember, we have this as a sub n, and say we'll call this b sub n. Now, one of the stipulations of the comparison test states that if we have a b sub n, 1 over 3n, that is greater than or equal to a sub n, and we know that b sub n converges, then by comparison test we know that then a sub n also converges. Now, let's take our b sub n. You may realize that this is just simply a geometric series with a ratio of 1/3. And as you know, a geometric series with a ratio of 1/3 is obviously less than 1, which means the series converges. So, since 1 over 3 to the n, or b sub n, dominates and is greater than 1 over 3 to the n plus n on the interval 0 to infinity, and we know that 1 over 3 to the n converges, that means that 1 over 3n plus n also converges by means of comparison test. The next video, we're going to cover the limit comparison test.